Okay, get this. What if I told you there's an animal on Earth that you can boil, freeze solid, crush under insane pressure, and blast with lethal radiation, and it just shakes it off and walks away like nothing happened? We're talking about the tardigrade, and let me tell you, its story is even weirder and more profound than you can possibly imagine.
And when I say tough, I am not kidding. Back in 2007, scientists actually sent a bunch of these little guys into low Earth orbit. They were exposed directly to the void of space, no protection. And when they got back, not only had many of them survived, but they were even able to reproduce. This makes them the only animal we know of that can handle raw, unprotected exposure to outer space. Just think about that for a second. So what does this absolute champion of survival even look like? Well, under a microscope, there are these kind of cute, 8-legged microscopic bears. It's why they got the nicknames water bear or moss piglet. They're tiny, usually less than a millimeter long, and you can find them pretty much everywhere on the planet, from the top of mountains to the bottom of the sea.
The sheer scale of what they can put up with is just mind-boggling. They can handle temperatures that are just a whisper away from absolute zero. That's as cold as things can possibly get. And on the other end, they're fine well above the boiling point of water. They can withstand pressure 6 times greater than what you'd feel in the deepest part of the ocean, and take on doses of radiation hundreds of times higher than what would be fatal for a human. It's almost unbelievable.
So this leads to the big question, right? How is any of this even possible? What kind of biological secrets does this tiny creature have that let it just defy conditions that would completely vaporize almost any other form of life we know?
Well, the answer isn't some kind of indestructible armor. Nope. It's actually about an incredible ability to basically hit the pause button on life itself.
This amazing trick is called anhydrobiosis, which literally means life without water. See, when a tardigrade is faced with a deadly lack of water, it can just shut down. It suspends its metabolism, dropping it to less than 0.01% of its normal rate. So it's not dead, it's just waiting.
This whole transformation process is really something else. As its environment dries out, the tardigrade pulls in its head and its legs, and it curls up into this tiny, dried-out little ball called a ton. This compact shape drastically cuts down its surface area and slows water loss, letting it pop into that state of suspended animation. You can just add a drop of water, sometimes even years later, and it comes back to life and just walks away. It's wild.
So how does this ton state actually work to protect them? Well, it's all about what's going on inside their cells. They basically have this whole molecular survival toolkit they can deploy. A special kind of sugar called trehalose replaces the water, turning the inside of the cell into a sort of protective glass. Then, other unique proteins create a kind of molecular scaffolding to hold all the important machinery in place so it doesn't break. It's this incredible, multi-layered defense system, all happening at the tiniest biological level. So okay, we've figured out how they survive. It's amazing stuff, but what if I told you their superpower of survival isn't even the most surprising thing about them? What if their very existence tells us a much deeper, much stranger story about the history of life itself? To figure that out, we have to look at their family tree, and that's where we find a really startling twist. You know, when you look at their family tree, you might expect them to be related to other super simple organisms. But as you can see here, that's not the case. They actually belong to the Panarthropoda group, which puts them right alongside much bigger, more complex animals like insects, spiders, and crustaceans. And this is the part that will bend your mind a little. The tardigrade's simple body isn't simple because it's some ancient, primitive life form. It's simple because it's the result of extreme evolutionary simplification. They didn't start out this way. They actually became this way by over millions of years, losing huge parts of their body plan. So how on earth do we know that? Well, the evidence is written right there in their genetic code. It's like a smoking gun. So to understand this, you got to know about something called Hox genes. Think of them as the master blueprint for building an animal's body. They're arranged on the chromosome in the same order as the body parts they control. So they tell the developing embryo where to put the head, the middle bits, and the tail end. This chart really tells the whole story. When scientists compared the ancestral blueprint of their family, the panarthropods, to the tardigrade's own genome, they found a massive gap. A whole bunch of genes that are responsible for building the entire middle section of an animal, like the thorax and abdomen of an insect, they are just completely gone in tardigrades, missing. So what does this actually mean? It means tardigrades are basically a head with a butt,
attached directly to it. I'm serious. They literally lost the genetic instructions for building a trunk. Their compact, simplified body is a highly evolved trait, an adaptation they achieved by deleting a massive chunk of their original body plan.
And hey, don't just take my word for it. The researchers who figured this out put it very clearly. Their whole body plan is the result of losing a region that their ancestors definitely had. So it turns out, evolution isn't always a straight line towards more and more complexity. Sometimes the most successful strategy is actually to simplify things.
So what's the big takeaway here? I mean, beyond being a super fascinating little creature, what can we actually learn from this tiny survivor? Well, it turns out tardigrades give us a really profound window into several huge scientific questions. They are a perfect case study for miniaturization, how complex life can evolve to get smaller and simpler. Their near indestructibility makes them a key player in astrobiology, helping us think about what kind of life might survive on other planets. And they show us these completely unique strategies for survival that we're only just beginning to understand. Strategies that could have applications in medicine, material science, you name it. They're basically a masterclass in adaptation.
You know, the story of the tardigrade really shows us that some of the biggest lessons about life, survival, and the strange paths of evolution can come from the absolute smallest packages. And it really makes you wonder, right? What other huge secrets are hiding out there in plain sight, just waiting for us to look close enough to see them?